Hey guys, welcome to today here on ARCRVA. Happy early 4th of July to all of you who are going to be here celebrating it in the good old USA. I've got a good video today. Came across a couple things that we needed parts for. Now, this item here particularly, we don't need the parts for, but because it has the particular issue that we will be doing on this. This is actually an old 650 watt BFG power supply. Now, this had actual Molex connectors on it, but we took all those out, replaced it with serial ATA connectors, so it's only a serial ATA power supply now. We removed the two 6-pin connectors for video cards and everything else. But both of these devices have the same problem. Blown capacitors. Now, these capacitors on this board are bulged, and I could have sworn one of these was leaking. Yeah, one of them is leaking. So this one actually has 1, 2, 3, 4 blown capacitors. Now, does the board still work? Yes. Is it stable? No. I was actually, when I put this FX CPU on it, I was trying to figure out why, and I didn't know until I looked at the capacitors recently and said, oh, well, they're blown. So I've got some known good capacitors here. We're going to get those replaced today. And there go 2 of them into the fan. So we've got that. Now I think, and I did, forget one thing. Let's push the table closer. I'm going to roll over here to my storage bin and get some RAM. Let's DDR2. DDR2. And we're good enough for 512. Use sticks of DDR2 RAM, or DDR RAM, sorry, DDR. So that way, when we get done fixing this, we're going to use this to test this after they're both fixed. Now, normally, I would say, don't do this. Okay, normally I would say this, but because we're in a bit of a bind on parts and everything at the moment, we need a 650 watt power supply. So, to do this, you will need a soldering iron. You will need the part that needs to be repaired. You will also need solder, so tell you what. Edit moment, and we're back after the edit. Alright, so a couple of parts I forgot here. You're going to need some solder, flux, and the brush to apply flux. You will also need, and I did have to special order these capacitors because I didn't have enough, the capacitors they're replacing. So what we need is 3300 microfarad, 10 volt, and 16 volts. So, I know for a fact I need 2 16 volts. Now, you can order these on eBay, really cheap. However, these are actually bigger than what I need them to be. So we're going to try and make this all work. Now, you might be wondering, well, Donald, why fix the power supply? Well, because normally when capacitors go, it's normally due to a surge in the system. Now, this particular surge could have been caused by, a surge into the power lines, you name it. I also need 4 10 volts. We've got that. So let's get our soldering iron heating up here. And what I've got here is a paper clip to jump the power supply on after everything's mounted into it. So that way we can actually test see to make sure that it is working again. Now what I've also got, there it is, hiding behind the cover is a hard drive to make sure that when we did the soldering job on this SATA rail here, because we are going to need 6 of these connectors in the system. Hopefully this will work. I've actually done this many a time before. It's worked fine and the power supplies continue to last. So it's normally due to a spike in surge or just cheap capacitors. Now, for a motherboard, the reason they will actually get blown, like these are, is because of bad power supply. Now, bad power supply will cause fluctuations in power, and the board tries to correct. And when the board is done trying to correct so many times, enough is enough, it gives up and starts blowing capacitors. So we're just waiting for the soldering iron to get hot. And we can begin soldering. Now, if you're really good at soldering, then yeah, you can actually do this. Now, is it a surefire way that it's going to fix the system? No, it isn't. I've ran into several cases where I've actually done this for a motherboard in particular, and it doesn't fix the board. It just fries, you know, the MOSFETs, everything is just gone at that point. But I do know that this board works. I've actually fixed a board before and it didn't work afterwards. And please excuse the snapping because that is the air purifier that we've got down here to get, you know, clean the air up a bit, this, that, and the other. So what I'm gonna do is just get this ready here. We're gonna see about how hot we are. Well, looks like we're getting there. Yeah, we're definitely getting there. Now, the other thing that you want is a bit of water for your sponge here. I don't have any water on it right now. I'm not overly worried for as long as we're going to be doing this repair. Now, the entire point of ARCRVA is Affordable, Reliable Computer Repair of Virginia. Now, VA is the state that we live in here at ARCRVA, obviously. It's a name and an acronym I came up with years ago, and it's just stuck. So, let's see if we are melting yet. Yep, we are officially melting. So, the way that you're going to want to do this is when you take the capacitor off, you will have a side with no line and a side with a line. The side with the line is negative, as designated by the capacitor. Now, when you go to actually replace capacitors, you can actually go to within, if I remember correctly, 10% of the voltage or microfarads. Now, I tend to replace, you know, in this case, 3300 microfarads 10 volt with a 3300 microfarad 10 volt. Why? Because then I know it's actually going to work. So let's get moving some parts here. I think we're going to have a problem here, because the one thing that we noticed with this power supply is it has a very high lead content solder on it. And it took, actually, one of my buddies that is actually going to be doing some videos with us at some point, me holding a heat gun and soldering iron to this all at the same time. So it looks like we're going to just be doing max heat on the soldering iron again. So bear with me, because I got to actually get some desoldering wire. Now, normally I wouldn't use this. This is just, I mean, it works great for certain applications. And in this particular application, it's going to have to work, because we've got to be able to get this desoldered enough, or the solder out of there enough, to be able to do its job correctly, so that way we can slip in the new parts. And because I bridged the connection, who cares, I'll just wipe it on me. That wasn't a good thing. And this is turning into a nightmare like the rest of this project has been so far. So, you're going to have to give me a minute here, because I've actually got to fight this whole thing. Debridged that connection, that's good. Let's see if we can get this thing melted. Now, at certain points on this, I've actually been able to, desolder certain wires and everything else. There we go. I've been able to desolder certain wires and everything. But when it came down to the desoldering, ooh, look at that. Look at that. Nice and blown. All leaky on the bottom. Now, could I desolder a few other things in this and take everything out? Yeah, most likely. But I'm lazy. And the next problem we've got is I've got to find the contact point for the next capacitor, which is a bit of a nightmare here, because I don't exactly know where it's at. I think I found, there's that one. And there's that one. Alright, hang on. Oh man. Yeah, this is why they actually switched to a low lead solder. Because it was just that much easier to deal with. Okay, so remove those. Which means I'm missing a point somewhere. It's got to be Normally I can tell where they're at, but this has been a bit of a trip trying to figure out which ones are which. Okay. There's one point. It's the next point has got to be around here somewhere. Well, don't get me wrong, but BFG did do a good job with this power supply. It's just a nightmare trying to deal with it. I got that out. Let's see where this actually pinned in it. Okay, I see now. I see. What I'm also gonna need, I didn't grab, is my other brush. Because there's actually leakage on the circuit board still. And there's my other brush all the way over. Okay, so we're gonna just put an end on that one. And I'll just scrape the crud out of here as best I can. Yeah, this is why you should get a UPS. Because it actually will help protect against this particular issue. It doesn't always 100% protect, but it should help. Now, if I'm right, the last one I took off is that. And if I'm right, that's a 10 volt. That's a 10 volt, and this is the 16. So the 16 volt goes in on the back here. So now all we do is do a quick touch there. Solder will hold that in place. At least the solder is there. Now it won't because I just broke it free. And I've got to push the other one through, which is why we got to do soldering work. Just take that pin end, bend that out of the way. I think the hole's coming into light here. Yep. There it is. Okay. So that one's there. This one goes in the host. Yes, we are. The one thing you don't want to do is hold too much heat for too long. And that buckle. So see, these repairs never go as planned. figure out what exactly is going on here because we need to get that pin through. I'm wondering if I can't do it from the back end going down. No. So it have to be from the front forward. And you know, I could have been actually out back tonight watching fireworks, but no. Instead, I'm in here making a video for you guys. Okay. You know what? We may need to do a complete edit here, because this is going to take some time. Alright, now that that intermission is done, we've got 1, 2, 3, 4, 5. Hang on. No, this counted 6. 6 blown capacitors off of this. Now, the problem that we were having is where this little rail is here, there's actually one of the holes for the capacitors, which is this one, right there next to it. So I had to literally, I do have it over here, I had to take the heat gun, heat it up, and push a pin through the melted solder and get the angle right on the hole, so that way we could finish getting this dealt with. So what I've also done is I've taken off the last 3, so now we got to put the 3 back on. Now another way to tell, it's probably going to be near impossible, but on this power supply, you know, to tell where negative is on the board, there's actually a little black line on the circuit board. And again, I don't know if you're going to be able to see this. Right about there. Little black line. Again, I don't know if you're going to be able to see it because my help isn't down here today to help me with it. So what we're going to do is start with the 16 volt back. Now what I did was I actually went in and desoldered the holes themselves this time because I was able to fluidize the solder enough to do it. I'm just gonna get a bit of fresh flux here. Dab it there. Take a bit of solder, put it back together. Then we can actually put everything together on it. Get solder joint. Let's get solder joint. So that. And that. You know, just nip the excess off. Throw it away. Nip it, but we're good. So we're gonna do the 10 volt, which is one of the last ones we'll have to do here. And I think I made a big boo-boo, so I may have to get another capacitor. Because the capacitors that are replacing the 16 volts are bigger in diameter, I've we've got no, it's just not gonna. So we'll grab that one and that in the hole. And to make this work, I'm gonna have to pass things around here. When you're actually doing this, by the way, it really sucks when you don't have the right capacitor diameters. Able to do is kind of move a bit of this and a bit of that around. What I'm hitting here is a bit of material that was added in here for holding stuff together while you're soldering it. And it's already soldered pieces, so breaking pieces of that off so we can get everything in here. And as you can tell, I did put music on. And there we go. The new one is in there. So again, flux. And a bit of solder. Now the only thing I'm going for is to put enough solder on there just to hold it, because that's all you want. Too much, too little, you could end up with dangerous contacts that you don't want to have. There's that, and one more to go. Now, not that I really don't care. I really don't. Yeah, this isn't a permanent fix. This is just to get you by if you really need to get by. Well, right now we kind of need to. Alright, we got one more to do. This one should be fairly straightforward and easy, but knowing me, it's not gonna be. Because, again, that one new capacitor is just larger than what it should be, and I should have actually, you know, messaged the guy on, you know, would have been nice to have the diameters of this, but oh well. There we go. I can turn the heat back down on this because You know, for this board, we're only going to need about 30 watts worth of power, so we don't need it that much. So, back together, see what happens. Let's see if I snap, crackle, and pop my way into history here. These have been removed. I'm just going to throw them over there on the floor. Because, hey, we got company coming tomorrow, I gotta clean up that one. Protective plastic shield back in. Now, get this, cover back in on a power supply. And again, I don't recommend doing this with a power supply because you're probably going to be asking for a lot more work than what you're used to. As you can very well see, we cut a big section of the video out because I had that many problems. So let's get this flipped around here. Set this back into place. Take my light bulb here, which I have to release, and put it back into place. And we'll start hooking everything back up. Big connect here. Alright, where's my others? I actually keep the magnets out of hard drives for this purpose because it makes an easy find on locating screws. So let's get this dealt with. Now again, the only reason I had that soldering iron here cranked up all the way to its max is because this solder on this board has high lead content, which is something you don't see anymore, and you probably won't ever see again, because this power supply was most likely assembled, if I'm not mistaken. Here's the fun part of actually putting one back together and screwing the board back in, because you gotta move that out of the way. Make sure you got enough room. And here we go again. Problem after problem, I tell you. Now I should be able to put it back in. Now the reason this one screw has that little plastic around it is because it is coming out and around the 24 pin line. So you really don't want nothing contacting there. So now we're just going to plug that in. And we're going to get everything pulled into place here. Make sure I can push my contact area. Alright, I can. Less screw in here. And all secured. One thing I gotta look for here is which screws on where. So there are two that are bigger, and I just found them. And they actually go here. The other issue you do run into when doing this is occasionally you may end up with a capacitor taller or bigger than what you normally had in here. Which, oh, we ran into it. There's that. But yeah, I mean, it's really just this simple. Now, would this power supply have worked overall if I didn't replace the capacitors? Yeah. But the reason we did the replacement isn't because of that. It's because of we're going to be using this particular power supply for our ARC server, and I want to make sure that, you know, that actually continues running for quite some time. So now what I'm doing is just putting this protective, you know, sheathing back on. I think I screwed up on this. This way. That'll wrap it that way. It should pull everything into place. And because this has got a little track on it. Now, we can plug this back in. This will feed just right down through a couple of wires here. This plug here is actually for the pins on the power supply itself. Alright. So we got that done, and just to protect ourselves, I've got this actually facing the right way. Two. So far, so good a matchup. Now all I'm going to do is put two screws in, and then we'll find out what's going to happen. But yeah, BFG did some really good stuff back in the day. Power supplies I'm not 100% certain on, but yeah, they did good with video cards. I've actually got a AGP BFG 55 or 5600 that I got actually from them on an RMA. So we'll cut off here. There. Now, when you go to jump a power supply, you jump the green wire with a ground wire, which is black always. And power supply's working. Alright. Time for our test drive. Make sure everything is hooked up correctly. And still working correctly as it should be. That's good. Now the reason I'm actually testing all of these connectors is to make sure that it's working going up the line. Which probably explains why I was having a problem with one of my test systems at one point. Alright, now for the news setup. Alright. So, working power supply again. Let's take a look at everything in here, make sure no capacitors read blue during the test power. Which I'm almost positive it didn't, but it never hurts to check. We are looking good. Alright, so let's button this whole thing up and get to the easier part of our video here. Now, I am going to show you with the motherboard because the circuit diagramming is about the same for how capacitors are installed. So I'll show you a different negative side here on this motherboard when I get the capacitors off. But yeah, I mean, this video is actually going along a lot easier than what it was for the initial phase 1 of this project. Because the initial phase 1 was a nightmare. I mean, we had problems desoldering stuff and everything else, and we're putting stuff back in, and it's honestly due to the high lead content, which is why everything went to a low lead content and things just became easy. Let me get one of my screwdrivers here. The reason I want a screwdriver is because when, moving everything around on this, I think we've been back IO on this, so I'm just doing this to back out some, maybe spring a case a bit more on that, but that's a lot better. Okay. Now, we have a working good power supply again. that down there on the floor. Got one important thing we need for this video. We need our box. Now, the mining stuff is turned off right now because we're running into a power supply issue with this project. And I wanted to make sure that, you know, we had a power supply for the ARC server. Just making sure we got enough heat here. What's my earbuds? Very much better. This might be another board that we're going to be doing some crazy stuff with because it looks like this might be a high lead high lead solder as well. Oh boy. And it's starting to look like it. This is lovely. I tell you, doing this stuff, this is why I normally throw them out. But because this is a very particular system that I'd like to keep running, and for the nostalgic reasons, we started moving some stuff. The problem we're gonna have here is I gotta grip this thing, put a serious pull on it. I mean, I could make this easier by taking the heatsink off. But I really don't feel like doing that. So I'm just doing it this way. That thing's in there. See if I can get a pull solder around it and just see if it can melt once there. That's gonna work. So now we gotta jack the heat up again. The reason I really don't like doing this to a motherboard is because the board is a lot more sensitive than the one in the power supply. And if you really do screw up the wrong way, you could very well be buying a new board here. One next one. So, where's that one? There's this one. Yeah, this is really. I can't begin to tell you guys how annoying this is. My lid solder reviews. Just go with that. I think I just broke the pin out of it, so let's see if I can get the other side out. Well, looks like I'm not going to get it out like that. So what I'll do is I'll just rip. See, now that one came out with its pin because I already broke the one pin free. I'm more interested in doing it. Now I am going to have to remove the heatsink because I did that. This is actually an old FX CPU socket 939 if I recall. I'll tell you here in a minute. Yeah, socket 939 Athlon 64 FX. The FX. Take this out. Take that out. Back plate off. Let's take a look here. There we go. Oh man. This whole project set here is just making me do stuff I really don't want to do. I'm telling you guys, this is really benign. Here I am trying to show you something that's really nice to do once in a while when you're in a bind. And there we go. I tell you, this high lead stuff, I'm kind of glad we switched over to a lower lead content, because it is a pain in the butt. That one came out a lot easier. Now, as you can tell on this board, there's a white side and a blue side where the capacitors were, and they were right here between these two parts here. Now, the negative is the dark blue side, positive is the other side. So what I'm going to do, and these capacitors that I'm using on this one were pulled from, a dead system, but the capacitors were definitely. What you gotta do is make sure that the wires line up with the right stuff. It's gonna be a problem. Is that it? Yes, it is. Like when I yanked one out, that created a clean hole. Which is one thing I always welcome. Open all these holes up here. So I would prefer to do that at this point and continue trying this. Open that one. And what I'll do, so where's my little pen I was using earlier? Well, looks like I'm losing stuff again, guys, so time for another break. Alright. Let's just say this will probably be the only time I do this video, or anyone like it. We got it out, all done. As you can tell, we are booted into the BIOS here. It is an Athlon 64 FX60 dual-core CPU, running at 2.6 gigahertz. Has a grand total of 2 megs of cache on the high end, and right now we've just got it testing with 512 megs of RAM in it, which ironically is running at DDR333. Odd. Let's see here if we can fix that. Because if I recall, it is 400 megahertz RAM. So we're going to set this to 400 megahertz. And clock mode is, I really don't care about that. Let's see if it reboots correctly. Now it took me a while to actually get this actually working right. Looks like it's gonna boot. And it does. But F2 is to get into the BIOS on this one. Okay, so it is reading it at 400 megahertz, you just have to manually set it. BIOSes back then were weird, because this is a CPU from the first 64-bit consumer side of things, especially from AMD. This is actually back when AMD won out, so yeah, it's going to be good to see this board getting used again. As to whether or not it'll fully be used, I don't know yet, but I think I'll figure something out for it, because this is actually another one of my first CPUs, like my AMD Athlon 3200 Plus Spartan Core was my first, full top-line AMD CPU. This one was up there as well. However, the board for this CPU, if I recall correctly, caught fire, fizzled out the entire audio on the board. The CPU was lucky enough to live. I kept using it till the board just finally died one day. But I did keep the CPU because I loved it. So that's it for this video. Like it if you like it, hate it if you hate it. I know there's about a lot of spacing out, probably quite a bit of idiocy with it, but we've got a working 650 watt power supply again, a working fully motherboard. Honestly, if you're in a pinch, do it. Replace the capacitors. Believe it or not, I had to order the capacitors for this power supply. It only costs $13 and some change, so we'll call it $14, not counting, the solder I already have and the soldering iron. That alone, you can get a small soldering iron kit probably from Walmart for around $10-20, so you can get and repair the power supply. If you've already got the stuff and you just need the capacitors, hey, it's worth it. But who am I to judge? Again, thumbs up if you like it, thumbs down if you hate it, and don't forget to subscribe. Who knows? But we have picked up subscribers and viewers lately, so let's have fun. Peace out. Happy 4th of July. I got stuff I need to do, and we're going to be setting fireworks off tomorrow. So have fun.